Now we are going to discuss about the reactions of chiral molecules. So there are different types of reactions of chiral molecules. These are the different types of reactions of chiral molecules. First one, reactions of chiral center where bonds are not broken. And the second one is reactions involving generation of new chiral center. And third one is reactions of chiral molecules with the optically active molecules. And the last one, fourth one is reactions of chiral molecules where bonds are broken. So let us see one by one. The first one, reactions of chiral center where bonds are not broken. So this is an example where chiral center that bonds will not be broken. So it is used to relate the configuration. In this chiral molecules, that is 2-methyl butanol, which will be treated with the hydrochloric acid to give 1-chloro-2-methyl butane. So here you will find the reaction CH3, CH2, CH, CH2OH, CH3, which are treatment with the hydrochloric acid. It will give 1-chloro-2-methyl butane. Here you will find that one, that hydroxy group will be replaced by the chlorine. It is present as such, there is no bond breakage. So it is example for the chiral molecules where bonds are not broken. The second one is reactions involved in generation of new chiral center. You will find this reaction. Here the compound is optically active, whereas the second compound is a meso one. Here it is the example S2-chlorobutane. In second position chlorine is present, CH3, CHCl, CH2, CH3, that is S2-chlorobutane. Which on addition of chlorine, it will be converted into one chlorine will take hydrogen, that will be eliminated as hydrogen chloride. So it will give SS form of 2,3 in second position, and the third position chlorine will be present. So it will give SS form of 2,3 dichlorobutane. If the chlorine is attached in the same position, then it will give a meso compound. See, if it is divided into two equal halves, the same environment is present in the opposite direction. Hence, it is a meso form. This will give a meso compound. So here it will give a generation of optically active compound. If the substitution occurs in some other position, then it will give meso form. That meso form of 2,3 dichlorobutane will be formed. Next reaction will be reactions of chiral molecules with the optically active reagent. In this method, the chiral molecules will react with the optically active reagent, and this type of reaction it is used to resolve the racemic mixture. So racemic mixture which contains equimolar concentration of both the isomers. The D isomer and L isomer will be present. It will be separated. It will be resoluted by this method. This is a malic acid, which is an example that will give the this type of reaction. So here the racemic mixture that will be treated with the reagent B. What will happen? It will be divided into two. That is minus BH plus A, and minus BH minus A will be added. So here we are adding the H plus. What will happen? That plus form will be separated as well as the minus form will be separated. The substance we have added that will be get back as BH. So the racemic mixture will be converted into individual enantiomers by this method. The last reaction is reactions of chiral molecules where bonds are broken. So this chiral molecules react with the halogen, which lead to breaking of the bond. So optically inactive compound is formed. So it contains the racemic form. Here we will find that one. This is the example, that is 1-chloro-2-methyl butane. So it is optically active, whereas on treatment with the chlorine in presence of light, it will be divided into two equal halves. So it will give the optically inactive compound, that is CH3, CH2, CCH3Cl, CH2Cl will be formed. That is 1,2-dichloro-2-methyl butane will be formed, which is optically inactive. I hope you could understand the various reactions of this chiral molecules. We will see the short recap of these chiral molecules. That is, first one is reactions of chiral molecules where bonds are not broken. Second one is reactions involved in generation of new chiral center. And the third one is reactions of chiral molecules with the optically active molecule. Then reactions of chiral molecules where bonds are broken. These are all the various type of reactions. I hope you could understand. Thank you.